and we're going to plow through the examples starting at 5. We did at last hour skip a few of like punching it into our calculator and doing some arithmetic, and we were able to make it through example 11. So that it worked out well. So let's go. Number 5 is where we left off yesterday. You should be very comfortable with the first 3 I do, and then you should really focus because there's some good stuff coming in the later section. Examples. So you have on number 5, all right, a right circular cylinder, and I did remember to press record so I can take these off. Forgot last hour. You're welcome, Deca people. Why isn't it erasing? Do I not have my thing plugged in? And it's not writing. Just a second. I can fix it. I'm a strong, independent, confident woman. I don't need to call the tech people in. I hope. Well, then we just go to, I do have digital notes, so then you just have to listen. All right, so hopefully this will write this time. Let's go check it out. So we have a right circular cylinder, so we're going to go draw that. The fact that it's right just means it's perpendicular to the ground. See, I am a strong, independent, capable woman. There we go. It's just not oblique or tilted. It has a radius that's growing. And you might say, how does a radius grow? This isn't a container in this problem. Most of your cylindrical problems this chapter are going to be containers that are filling up or leaking some sort of substance. But this is like a slug in a machine shop. And that machine is squishing it down and stretching it out, right? Because its height is shrinking. So maybe it's trying to make like slugs or something for a car part or something. Does that make sense? It's the whole shape is changing. It's not a container. All right, so what did they give us? Let's review from yesterday. They gave us our dr dt, and it was growing, so we use a positive. You can drop putting your labels on those if you want now. Just know at the end we need a good label. And its height, so our dh dt, is shrinking, so that indicates a negative rate of change. It says, what are we supposed to find? And the volume of the cylinder's rate of change. At the instant, we've stretched it to 10 feet high. So H is 10, R is H. You should feel very comfortable unless you were absent yesterday. Uh-oh. Were any of you guys absent? Oh, sweet. That would suck. All right, so anyway, now we need our equation that relates the volume of a cylinder to its height and its radius. It's not expected that you know that, but you kind of should, because volume for any figure, you do the area of a face or the base, which is pi r squared, and you bring it up with its height. That's why a box is length times width. You cover the bottom times height. That's the volumetric model for all shapes. So I'm going to write V equals. That's what I call getting your poop in a group, getting it ready to roll. Now what we're going to do is start the machine. It's going to start changing everything with regards to everything else. So that's our derivative. So we'll take our derivative with respect to time of the left, our dv dt. I'm going to circle that. You're going to find that you're going to want to later when they get a little more complicated, because I didn't on one last hour and I lost track. I'm like, what am I finding again? And they're like, dh dt. I'm like, oh, okay. So it took us a while. All right, so dv dt is equal to the derivative of pi r squared h. Constants go out front, so I will be moving that out front. Now it's really important for you to notice, kids, that this is a product. And it's a product of functions. They're functions of time. Like, it's not f of x and g of x, or f changing as x changes and g changing as x changes. It's actually r of t and h of t. But they're two functions, so I have to use my product rule. So beware of that, because sometimes, a lot of times with the related rates, even though I know Ben knows the product rule, a lot of times what kids will do is they'll just go, oh, 2r dr dt times d. They'll take just each piece separately. So let's go do our first. I'm going to leave my pi out front, and I'm going to do my first, which is r squared, right? D second would be dh dt. plus my second, which is h, and then you guys go ahead and write down what you think the derivative of r squared is with respect to time, and then just check it when I write it. Again, I'm recording, so I'm not going to be asking a lot of questions. They can't hear your answers, so I kind of have to say all the answers. Does that make sense? I'm recording off of this right here. I don't like to wear the headset. All right, so you should have written the derivative of r squared is 2r to the first times the derivative of the guts. And those of you watching, it went up the screen, but we wrote dr dt after that 2r. I just don't have my window enlarged enough. All right, so at this point, this is where we went and we plugged everything in. If we didn't have it, we went and found it. All right, so pi is a constant. Our radius, we're going to stop this machine when the radius was 8. Okay, so I do 8 squared times. My dh dt was given as a -3 because it was being shrunk. My h, I'm stopping when h is 10. 2 is a constant. R was 8. And dr dt was 2. At this point, I'm confident you guys could run that through a calculator, round it to 3 decimal places, or if it was exact, you could just do it, correct? I'm not going to do the arithmetic. That's where we're going to save some time. But I do want to make sure you've got the label correctly. So when we're done, go ahead. I'm not going to do the arithmetic today. If it proves to be a problem later, I'll go finish arithmetic. You okay with that, Ben? Can I not do it? You want me to go do it?
I did it. I don't know what you're saying.
What's 8 squared? Times -3. And then I'd have to add 10 times 2 times 8 times 2. And I'd have all that pi. I don't want to do it. 128 pi is what you said? All right, so let's write that down since you did it. Thank you for doing that for me. Actually, if you want to do that, then you can get a complete answer. Now it's the label I want you to look at. What did we find? We found the rate that the volume was changing, and our time unit was given in what? Minutes. So it's something per minute. Per minute. What do we measure volume in? Cubic. And our unit of measure up here is feet. So it'd be feet cubed per minute. We're not going to do the second one because it's similar to the ones we did yesterday in Delta Math, and I looked and it looked like you guys did just fine on that. So that allows us to move on. All right, so this guy right here, we have an oil tanker now. It's not just some random like rectangle. It's an oil tanker. It's spilled oil. That oil is spreading in a circular pattern. Its radius is increasing. So I like to go like that so I know that my radius is increasing. And it tells me the rate, so I'm going to go over here and do my dr dt is equal to 50. All right. And we're not going to do both the circumference and the area because I would call this like an easy level one right now. So we'll just do the area to save some time. So I'm supposed to find dA dt at the instant that oil has spread out to a 20-foot radius. All right. You should have the algorithm down right now, right? You should be going, all right, I need a formula. For area of a circle, it's pi r squared. You should go, all right, I got it. Then you're actually going to have the oil spill and the radius start to change. Mathematically, that's a derivative that you're going to take. So we're going to take the derivative on the left, which is actually what I'm looking for, is equal to pi times, and again, just keep that constant out front. Bethany, Michael, but the root, isn't it the product rule? Sure. If you want to go first, d second, you'd go first, and then you go d second, right? Plus second d first, and what's the derivative of pi? Because it's a constant. You can answer me. 0. So it's not the product of two functions, it's the product of a constant and a function. So that's just leave the constant out front, take the derivative of the rest, and this is the point where we go plug all our stuff in. Pi is a pi, 2 is a 2. We're stopping this when the radius is 20, and we've got our dr dt being 50, right? Do I need to go to my calculator for that? Probably not. I've got 50 times 40, right? So 2,000. So I have 2,000 pi, and then you go ahead and put a good label on there. Because right now, actually, you should be good with everything. I'm just a little worried about the label because it's such an easy point to get. I don't want you losing that. There's always a point for it. So when you're deciding on your label, you say it's units of measure per area per unit of measure for time. The time one's a piece of cake. The area one would be measured in feet squared, right? And it'd be per minute. So if we go tack that on, feet squared per minute. You should have been in a pretty good comfort zone with those. Where you actually, you're nodding. They're nodding. Those of you who, I think I have 6 people gone today, which is unusual for this class. There's Decca and something else. I think sick people. All right, now it's going to get a little different. All right, this is a silly problem. Like Hannah and her boyfriend, who like to hang out in my hallway over here, like he's playing a. Let's change this, right, to Jonah. Alright, so on all of YouTube for all to see. See, I did it, didn't I? She said I couldn't embarrass her today, and I'm like, well, maybe. I know what problem's coming up. So Jonah's going to pay a late night visit to his girlfriend, Hannah, in hopes of sneaking her out of her house after curfew. Naughty, naughty. He hauls a 25-foot ladder to her house, leans it against the side of her house because he's going to climb up it and go into her bedroom. Naughty, naughty, naughty. Right? And this problem does scream calculus to me. Actually, it's a dumb stem of a problem, but they get better. All right, so soon after Jonah reaches the top of the ladder, Hannah's dad, what's your dad's name?
I don't know.
Hannah's dad pulls into the driveway. Right? And he's like, what? And he kicks the ladder out. And Jonah starts to plummet to the ground. Okay? So it says, he begins to pull the lower end from the house at a rate of, that's going to be changing, it needs a variable. So you're going to need to add things to your picture. Also, the ladder is going to slide down. It needs a variable. The 25 can stay. We didn't have any of those yesterday, but I talked about it. I believe I did in both classes. Why is the 25 going to be able to just stay there? The ladder's length does not change. Now, if it was an airplane flying this way and an airplane flying this way, then I do need a variable over there because that hypotenuse will change. But this ladder is just falling. So, and the calculus of it is actually interesting too. It'll make some things click now when we start doing applications where you're like, oh, I get kind of why that worked when it was just not in an application. So here's what we've got. We've got dx dt, and it's getting longer. So x is growing, correct? So that's a positive. What are we supposed to find? How fast Jonah is falling to the ground? Because maybe he gets a concussion if he falls faster than a certain rate per second, right? So we're going to do dy dt at the instant when Dad has pulled the ladder out, so the x is 7 feet. Are we good so far? Are we good? Did it work? No. Dang it. Do I have to keep trying? He keeps challenging me. All right, here we go. So up here, I need an equation for these. Who knows what you're going to write down? What relates everything in my picture? The Pythagorean Theorem. Yeah, let's go ahead and if you want to label these G for given, F for find, some people like to do that, specifically because when they get a little more complicated, circling that find is going to be kind of important. But I know that x squared plus y squared has to equal c squared. Again, be very certain why that 25 gets to go on my picture, and in my equation it is not changing. Which is why when I take its derivative, the derivative of any constant is 0. That should really make sense to you in the context of the problem, right? Because the derivative of this is the derivative of the ladder's length, and it's not changing. So that kind of constant's going to 0 kind of makes sense in that context. Don't you agree? All right, so now I need to take the derivative of, and I'm just going to box the whole thing in. The right side would go to 0. You write down. I normally ask, but again, I'm just going to have you write and then check that what you think the derivative of x squared is. If you write 2x, at this point that kind of makes me sad, right? 2x, if that had been the derivative of x squared, or dy, dx. then it's twice x. Ours is twice x times the rate that x is changing, plus 2y times the rate that y is changing. How are we doing so far? Are we good? Thumbs up. Thank you. All right. Do you remember yesterday what I said to just make the arithmetic then easier? Yeah. Get the 2 out. Divide everything through by a 2. And then we go plug stuff in. Okay, we actually stop it. And we go, okay, what's happening at this time? Keep in mind, I'm trying to find dy dt, so I am going to circle that so I don't lose track of what I'm trying to find. I'm stopping this when x was a 7, so I'm going to have a 7 times. dx dt was a positive 2. All right, y I don't know, so I'm just going to put it in there. dy dt I don't know. And then you have to remember from yesterday, how many unknowns did I say you could have in the problem? 1. When you have 2 or 3, you'd never have 4. You have to go find them. You either missed it in the stem of the problem or you can find it from the diagram. This is a you can find it. Now that I took the derivative, I'm stopping the ladder. So you can go ahead and put your 7 down here. Not at the beginning of the problem though. Does that make sense? All right. So then you need to figure out y by using the Pythagorean theorem. You guys go do it. Just do y squared plus 7 squared equals 25 squared. It worked out nice last hour. It was a 24? Perfect. So I'm going to, just for the people watching it at home, they are solving 7 squared plus y squared equals 25 squared, and they said they got a 24. So we're going to go say 14 plus 24 y dy dt, 24 dy dt is equal to 0. And then Ashley had subtract 14, right? And then I divide by 24, because remember I'm trying to solve this for the rate that Jonah is falling down her house wall, which would be at a rate of negative 14/24, also known as negative 7/12. Should make sense that it's negative. Do you get why I am going to pose that question? Because it's important. Do you get why, Kristen, it makes sense that our answer was negative? Why? Yeah, because y is shrinking while x is growing. So if I had a positive, I go, wait a minute, that he's not continuing to climb farther up the house, right? And then this is a length, so this would be in feet per second. How are we doing? Are we hanging in there? Awesome. You guys are troopers. It is a lot of notes today, but let's just get it over with so we can have a nice Friday. You can choose to work in groups tomorrow or on your own, whatever you want to do. So it says a camera is mounted 3,000 feet from a rocket's launching pad. Notice that can, and you should if it wasn't there, go on my picture. I'm not moving the camera. It's pivoting as the rocket's launch. So the rocket gets launched, the camera is going like this and tracking it. Does that make sense? But it is going to stay 3,000 feet from the base of the rocket. So it's pivoting, and it's going to keep that rocket in focus as it tracks it up into space. The rocket is rising. It needs a variable because it's changing. Last hour they chose h, so to keep your notes consistent, we're going to go with an h. All right? So it says that it's rising vertically, and that's going to be positive because h is going to grow. The height is going to grow as the rocket stops plummeting to the ground. All right? And it says, if the rocket is rising vertically at 800 feet, how fast is the camera to rocket distance? I have to draw that in. I have to note that that is changing. So what do I have to put on it? A variable. They chose z last hour, so I'm just going to stick with it because I have people who are going to be working together out of different hours. Okay? So we're just going to do that. What am I supposed to find? dz dt at the instant when our h reaches 4,000 feet. This one you should be comfortable with. The next one should make you a little bit uncomfortable because this is Pythagorean again. So I might stop partway through this one. Are you okay? But the setup's going. We would say h squared plus our 3,000 squared is equal to our z squared. Take its derivative. And I'm just going to not split it. I'm just going to go d dt, and I'm going to bracket this in, indicating do it to both sides. So then I can save some writing. I think we're ready to start like condensing our steps a little bit. So, Cage, when you do that, what'd you say? I have to talk to you guys. I'm sorry. What would you say the derivative of h squared is?
2h dh.
Yep, so he's going to go 2h dh. I want to take this one a little farther. What's the derivative of the constant? 0. Like, this rate is not changing here. It's staying stagnant throughout the whole problem. So its rate of change is 0. So plus 0 is equal to twice z times dz dt. Let's see if you remember from yesterday. What did I suggest to this problem you do next? Divide things by 2 to keep your arithmetic at a minimum. Something's missing in there. Just, you don't even need to write it in. We're going to go dot, 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 because the rest is plug and chug. But what is going to be missing that needs to be found? Z, right? So remember, once you take the derivative, you can stop the rocket at its 4,000 feet. What's Z? 5,000. Yeah, if you didn't know that, it's that perfect Pythagorean triple. 3, 4, 5 is pretty common because we know Tyler knows how to do the Pythagorean Theorem, so we might as well give him a nice one. All right, so you can just, that's not the calculus of it. I would hope you do. Do you? Do you? Okay, good. Are you sure? All right. And this one's label would be in just a length, feet per, what was the time unit? Second. All right, now if you tuned out, tune back in. Because now it gets a little bit more interesting and something else happens. Same problem. So we still have our dh dt, which I believe was 800. I've done this twice now, so I think I've got that correct. We're still launching the rocket. The camera is still pivoting and tracking it. We're still going to stop when it's 4,000 feet off the ground, but we're looking at how fast the angle is changing. See, so when it's tracking it, wouldn't the angle be growing? We're going to get a positive answer, right? It needs a variable, though. I think you should always choose theta, because that's how it's most common, like if you were to Google related rates or try to get help from other sources, which I have no problem with. It's pretty universal to use a theta in there. Some people might have used an A for altitude here. You know what I mean? But just so if you're like, I need more, go ahead and do that. Now, here's the deal. I need a relationship between h, 3,000, and theta. Yeah, tangent. Okay? So I'm going to say, now somebody last hour, we put the z on there, and somebody said sine of theta is h over z. I said, you can do that, right? That's just a little more missing parts, though. So I like to work with the constant. So I'd at least use this adjacent side. You could do cosine 3,000 over, you know what I mean? But I like the tangent. It just stands out to me, so I'm going to stick with it. And it stood out to you too, Carissa, so I'm guessing it was probably the one most of you guys would have chose, but it's not the only route. So tangent of theta is equal to opposite over adjacent. Okay? The minute you set up your equation is the minute after you launch the rocket. Mathematically, you take a derivative, right? So I'm launching the rocket with my math. Tangent theta, you guys look really focused. What do you think I'm going to do with the 1 over 3,000? It's technically a constant. Yeah, I'm just going to go 1 over 3,000 times the derivative of h. Who remembers the derivative of tangent? They all did last hour, so I was like, okay, I'm saying, though I said, if you guys can't answer me, we're going to have to go back and do the sine, because you all know the derivative of sine is cosine. But I asked my third hour, I said, what's the derivative of tangent? I had a pretty wide open secant squared. So if you forgot that, though, and you're on a test, you're going to have to bail and go back to a different ratio. Makes sense, right, Jacob? So we're going to say secant squared theta is equal to 1 over 3,000 d theta dt, and I want you to stare at that and absorb the most common mistake kids make when it goes trig. I did it on purpose. For some reason, when it goes trig, this mistake gets made very often. Raise your hand if you see it. I won't call on you. I just want to know if you guys see what's missing. Oh, by the way, I forgot to put my find on there. So this is my given. I'll go do that while you're kind of analyzing it. It says find how fast the angle is changing. at the instant that the height was 4,000. And that finds important because that should trigger my mistake. What did I forget? Yeah, go ahead, Tony.
Theta.
Yeah. Yeah, theta prime. I like d theta dt, but same thing. The derivative of tangent t. And I'm doing this because I do still have some people who that kind of mess. The derivative of tangent t is secant squared t times the derivative of the guts, dt dt. Right? But the derivative of tangent theta is secant squared times, and if you couldn't hear him, those of you listening, he said theta prime, and I said I prefer d theta dt, but if you can keep your prime straight, I guess I'm okay with it. All right, here's the problem. I'm now at the point where, what am I solving for again? Because I've got 3 variables up there right now. D theta dt, I would circle it. I would go put in what was given. 1 over 3,000, our dh dt was an 800 in the given. So it seems like I'm expected to be able to find what secant squared theta is. Just kind of absorb that question. I can't have 2 unknowns, and I currently have an unknown secant squared theta. I must somehow have been taught, because I'm not going to throw something at you you can't do. Anything that's not in the given that you need to find, you know how to find it. This one's not Pythagorean theorem, but what do you think?
You can find cosine of
There, okay, exactly. She's got to go up and say, okay, I've been taught SOHCAHTOA, correct? I've been taught that cosine is adjacent over hypotenuse, not by Mrs. LaRue, but by Mr. Bloom, probably in geometry or wherever, right? And you were also taught in pre-calc that secant is what? 1 over, or the flip. So we have to do not aw squared, but ha squared. Do I have it? Do I have the hypotenuse and the adjacent? No, but remember I'm stopping when this is 4,000. See, so I've kind of got to troubleshoot here, but you know how to do it all. That's what I always, BC is used to me saying that when they're stuck. I say, you do know how to do that. And then they're like, oh yeah, all right? You do know this. What was Z? We found it already, but 5,000, yep. Okay, so we're going to do hypotenuse, 5,000 over 3,000, which we can reduce to 5/3, and we're going to square it. So I'm going to replace my secant squared with a 25 over 9, right? I'm looking for the d theta dt, so that's still my unknown variable. Now the arithmetic of it I am going to do, because if you're non-calculator active, this would be a reasonable request for you to know how to do a cleanup like this. So let's knock down a couple zeros. Okay, have a 1/30th. Instead of dividing by 25/9, what am I going to do? Multiplied by 9/25, right? You'd hate to get one wrong just because you couldn't do the arithmetic, so we're going to actually do one out here. What did we say, 9/25 over here? Yeah, so 9/25. I'm going to do any canceling that I can. I'm going to take out a 3 and a 3. Is there anything else I can clean up? Oh, 8 and 10. Let's take out a 2. 4 there and a 5 here. It's getting a little messy, but you should be fine with it. It's 4th grade math, right? On the top, it looks like I have a 4 left and a 3 left, and I would have done that neater if I had more space. But I have a 12. And on the bottom, I have 5 times 125, 125. You might say, why did you go through all the arithmetic of that one? I really, really, really wanted to get to it just so you understand what it represents. So the next thing I say is kind of important. So the label. Be a little careful. I want you to kind of think through how you decide what your label is. It has to do with what this is measured in and what this is measured in. Last hour when I asked, I said, what do we measure angles in? And they said degrees. And I said, not anymore. What do we measure angles in? Radians. This is radians per, is it minute? Second. Okay, thank you. Radians per second. Now, I asked them last hour, I said, do you know how many degrees are in a radian? They didn't know, but they knew how many were in pi radians. How many degrees are in pi radians? Right, so if we did 180 divided by pi, we would get how many degrees are in 1 radian. And it was like 58-ish, I think they said. I can't quite remember. But if you want to answer in degrees, you would have to do 12 125ths times 58 point, was it 57.2? Oh, then I probably should have said about 57 degrees. Most people don't want to do that though. But then you better not label it degrees per. Do you see where those labels are really important? What is 12 125ths times 57? How many degrees is it changing? Because we have a better concept of the size of a degree. 360, right? The size of a radian. How many degrees is it?
4.407.
So about 4.5 degrees per second is what that's elevating. Okay? Good problem? I love it. All right, the next one up. Listen carefully on this one. In BC on Monday this week, we stopped and did a related rate review because we're learning new stuff. Not as much as you learn in here, probably like 60% of the new content that you guys learn, they learn. Their task actually is to retain all of one while learning some new stuff. So we had to stop and I said, let's try related rates. And I found they remembered everything except this kind. Almost every group was like, how do you do that kind again? So I'm going to do something a little different on here. We're going to read this. Sand is poured onto a beach, creating a cone whose radius is always twice the height. I'm going to point here and write, and they did really well in third hour, so I think this helped. When you are given the dimensions, the radius is twice the height, or the height is a third the radius, something like that, where they don't give you what they are, but they give you their dimensions. That's going to imply or trigger something that you're going to do to make the problem way easier. So we'll fill that in later. But we've got this conical pile, and I'm drawing it like a really wide one because it said the radius, put an R on it because it's changing, is always going to be twice the height. So it's going to be kind of a flat pile of sand. The minute you get those dimensions, I want you to write 2 statements below here. The radius is twice the height. I want you to write that down. It will help. And then I want you to write the height is 1/2 of the radius. One of these relationships is going to make this problem way easier than it'll be if you don't use it. Good to go? So let me see what it tells me. If sand is being poured on the pile at this rate, what do you think that's a rate of change of? Look at the label. What's it a rate of change of? The volume. Excellent, you guys. So we're given dV dt. I have to decide if it's positive or negative, but the pile is growing. Sand's being dumped on it. So I'm obviously going to use this. This is the important part right here. So if you tuned out, tune in. Okay? What you're being asked to find, how fast is the height changing when the height is 2 inches? What variable do you not see over here? I should point at it so the people watching, you don't see anything about the radius, correct? So if you want to avoid having to do a product rule and finding the radius and finding the dr dt, when you set up your formula for volume of a cone, which it's not expected you remember, it's 1/3 pi r squared h. But I call it pi thirds r squared h. It's actually 1/3 of the cylinder in which it sits. Okay, there it is. If I launched into a derivative right now, I'd have pi thirds and then product rule. First, second plus second first, and I'd have to work with the radius and how the radius was changing. Do you see where this is going? I'm going to say, hey, I only need dh dt when h is 2, and I can get h, right? If I replace r with twice h. So that tells me which one I want to choose. I want to keep the h in there, so I'm going to replace the r. Did you digest that one, Ashley? So you got to kind of be a problem solver, otherwise the problem becomes way more difficult than it needs to be. So I'm going to replace the r. Now, if this had said dr dt when r equals, then I would have chose this guy because I want to maintain all the r stuff. So I'm going to go replace that guy with a 2h. H. I have not done any calculus yet. I've not started to pour the sand, and I'm still not going to, Bethany. I'm going to clean this up a little bit. So I'm going to go like that. If I squared the 2, I'd have a 4. So I'm going to go 4 pi over 3, and then I'd have h squared times h. H cubed. I still have not done any calculus, which is kind of weird because there's a lot on the board. Now I'm going to pour the sand. What do I mean when I say that? Now I'm going to pour the sand. I'm going to start the what? Calculus. I'm going to take a derivative of both sides, and now it only has one variable. Yep.
Can you do it the other way, like where if you didn't change R to H?
You could. And then you would have to say, well, what is R when H is 2? And you'd have to go over here and say, well, it would be 4. And what's dr dt? Well, if dh dt is 2 and H is a half of R, then dh dt is a half dr dt. Like, you'd have to think that out. There's more thought involved. So I wouldn't suggest it, because right now when I take my dv dt, I've got 4 pi thirds, a constant, times 3h squared times what I am looking for. Does that make sense? What was I looking for? I lost. This is the one last year. I was like, what are we looking for? I'm looking for what? dh dt. Do I know the other two unknowns, the dv dt and the h? Yes or no? I do, right? I've got the dv dt. I'm not going to write it, but what would I replace that with? 20 in the given. Okay? And I'm stopping this when h is 2. I'm not going to do the arithmetic of it. Plus, I ran out of real estate on my screen. But let's talk about its label. It's volume changing. Volume in this situation would be measured in. Oh, it's not volume changing.
It's height.
It's height. See, I did it again. I did it both hours. I remember I said there was a problem. I lost track of what I was finding, and I circled it, and I still did it. What would h be measured in? Inches, and then per second. Amazing. All right. Let's see. This one, if you turn the page, this is our last one. Yours has an accidental screenshot of this on top of it. This is going to be tomorrow. So we're done today as soon as I finish this next one. What time is this hour over?
16.
Oh, we'll have some extra. You're done a little earlier, and it's because I haven't been talking to you guys as much. At that time, when we're done with 10, I'll pass out the worksheet. You can choose to get a head start on it, so you can finish in class tomorrow. Or if you're like, I am so over related rates today, I'm going to wait, so that's fine too. But then you'll have some over the weekend. That's fair, right? So let's wrap up this last one. I do need you to take some time to write this down, because yours got laid over with something. We're going to do one more. You can do it. You got this, boo. So you're just going to need to, do you know what I'm talking about? Yours has kind of got a little problem with it. Huh?
You know, it wasn't obvious.
No, well, yeah, it's like started and then somehow I must have hit paste by accident. I don't know, it pasted what I pasted on the other page. It's a clerical error. I do want to do the original number 10. It's actually a very good problem. Right now, I would hope half of you understand this one. Okay, this is about as hard as they get until they get different. So I don't expect everyone to be golden on number 10 till test time. Those of you watching the video, I'm pausing because we have a problem with the number 10. It got cut off, so they're copying it down, and it's an important one. So while they're doing that, I'm going to start the picture. Vertex down, conical tank. This has got water in it. So I'm going to go put a water level. And what's the water doing? It's draining. I'm going to go like that so I know the water level is going down. All right, are we ready? Okay, so it says it's draining at a rate of, this is a volume change with that cubic, so I'm going to write what am I given, dv dt is equal to, and just to make sure you're paying attention because I have been talking a lot today. I don't do this very often, but sometimes it's necessary. What's wrong, guys, with what I wrote? I did it on purpose just to keep you sharp. Oh, I did put the units, but I'm not doing that anymore. What'd you say?
It's draining.
It's draining. Watch out for that, okay? Because you'd hate for that to throw your answer off and you'd be like, what? Why is my water level going up when this is leaking water? Because your answer would end up being, we need to get a negative answer. So then we're talking about how fast the water level is falling. I need a variable on that, on the water level. Okay, so I'm going to go like that. And I'm supposed to do that the instant there's only 12 meters, although that's a huge cone. Holy smokes. Probably shouldn't use meters as the unit of measure, because a meter's like 3 feet. That cone is like, that is quite the receptacle. Oh, do you get what I'm saying? That's not a good unit choice. Centimeters would have been better. All right, anyway, whatever. So, here's the deal. What didn't I use yet? In the stem of the problem, those dimensions, correct? The dimensions of the, and I'm going to go, I should have done the water in blue, and I didn't. So I'm going to do the cone in blue here. But it's the go ahead and move that away. Go. Okay, perfect. The dimensions of the cone are, it's 16 meters high. That can go on my picture. Understand why? You should be going, I feel like you guys are getting this, right? Why are you nodding when I said the 16 can go on that blue line? I'm not changing the receptacle. It's leaking, but it's not changing. My 4 can go on here. I want you to write the 2. These, by the way, this has now become a geometry similar triangle question. You learned in geometry that when you have 2 triangles that are exactly the same shape, right, but one's been shrunk down, everything's in proportion. It was actually called the angle similarity theorem. Ring a bell? You're nodding. Like, everything comes back in this class, not just algebra or pre-calc. Anyway, so these are in the same dimensions. So remember what I told you about those dimensions. I want to either say the height is 4 times the radius. I'll decide which one I want. Or what else? The radius is what? 1/4 of the height. I'll decide which later. Okay, but if you forget to write it, I think you're going to forget to replace it. So we're going to put that step right in here. Volume of a cone. Okay, so here's my given. Here's my find. Volume of a cone is 1/3 or pi thirds r squared h. You don't necessarily have to remember that. Now, I want you guys to go make the replacement based on this. Yes?
0 pi over 3 pi r.
Oh, yeah, I'm losing it. Pi thirds r squared h. Thank you for catching that. It means you're listening. All right, so to wrap the hour up here, you're going to decide. Now, again, you could go launch into product rule, but then your brain has to find the r for you at that time, the dr dt for you at that time, and do the product rule correctly, and have twice the amount of numbers to substitute in. So since this is all about h, what we're going to do is keep the h and replace the r with 1/4 h. Are you good with that move, Joel? Because that's really actually, that's what they forgot in BC this week, is they were like, what do we do again? Are you good with, okay? So now even again, I'm not going to poke a hole in the cone yet. It's not going to leak water yet because I want to clean it up, and I suggest you always do as well. So this looks like I'd have a pi on the top and a 3 times 16 on the bottom, so 48. And then an h squared times an h. Make sure I'm not getting sloppy because I'm actually like been doing this all day and getting a little, yep. When I do 1/4 squared, I'll get 1/16. And then I just kind of did some arithmetic in my head, which I probably shouldn't do, but I'm getting a little. There's a lot of talking, and BC has a really hard lesson too. Luckily, I have a prep between the two. Because this is a whammy of a day. It was the last day of the longest proofs for geometry, related rates, which is usually really hard. You guys seem to be doing well. And then BC, I have to do Euler's method, which is new for them, so they're going to be like, ah. All right. Anyway, now I'll poke a hole in it. Bam! And it starts to leak. Okay? That's my derivative. Do you mind if because I am getting a little punchy, and I feel like you're getting it, I'm going to go like this. You okay with that? I just don't want to do a rewrite. So my dv dt is going to equal, what am I going to do with that pi 48? What am I going to do with it? We're not going to do first d second plus second d first because when one of them's a constant, it just ends up being first d second. 3h squared times dh dt, which is what I'm trying to find. How are we doing? All right, so then we go put our v in. What's going in for v? -2. And our h is, I've erased it. What was it? 12. When h is 12. So you'd go plug all that in, solving it for dh dt. Did you already do it? Did you do it too already? What was it? -2 all over 9 pi. That sounds right from last hour. Okay, so I'm going to keep it. Now, if you had to go decimal, you'd have to parenthesize that. Now let's get a label on it. It is a height changing. Look at what I circled. Inches, yes. Per second. We are done. Was it minutes? Meters. See, I'm getting sloppy. I'm done. All right, pause. Oh, those of you at home, the worksheet, they're going to choose if they want to not have homework over the weekend and maybe get it done, 8 or 9 of them done at home. We're also going to skip number 1, and I'm going to give them the formula for number 5, so don't turn the video off yet. And I'll link this. I think all of you guys who are gone grabbed a worksheet yesterday, but just in case you didn't, I'll put a PDF on the slide. So go ahead and write due Monday. Tomorrow you'll have 45 minutes. We're just going to do one quick multiple choice one tomorrow. So you budget your time. Go ahead and cross off number 1. That's more of a physics-based question, which you don't really need to do. It's not hard, but number 1 you can cross off. Number 5, if there is ever a formula you need, you can go ahead and Google it, but I think some of you will get to number 5 if you decide to do it, like even in a study hall tomorrow. A sphere. Above sphere, maybe go ahead and circle it. Right, V equals the volume of a sphere is 4/3 pi r cubed, and the surface area of the sphere is 4 pi r squared. I don't know if you guys remember that. I don't know that you'll get, like, don't do the whole thing because we have close to an hour to work tomorrow. So, but I don't think you need another formula like that. Well, there's a sphere again in 14. There's the cylinder, but that's already in your notes. So I think that's the only one I need to give you. I'm gonna see if there's a ladder one in here because we skipped the ladder problem. Yeah, you can cross off 26. We're gonna wait on the shadow problem. You can just go ahead and cross it out. You're gonna forget how to do it. Every year people do. That's the hardest one for them. So 26 you can cross off with the shadow. We'll deal with that at another time. All right. So are we good? What's your homework? Nothing really, unless you're like, I have a busy weekend. Then I would do some. I would hope that you get half of it done in class tomorrow. They do take a while though, but they start off easy. How'd it go? You get it? You get it, Paige?
Yeah.
This is a big section. Sometimes there's tears in this one. Oops, I forgot to turn my thing off.